One, welcome to the weekly classes for learning how to write smart contract with a script. An script is a TypeScript framework for writing smart contract on Bitcoin SB. So today we are going to look at the stateful contracts. So as usual, you have to visit the official site of script.io, then go to documentation, and in case if you didn't register with script, you have to sign up for your free account so that you will get your own API key in order to integrate script services. So if you come to the documentation under how to write a contract, we have discussed on script context already, and today we are going to look at the stateful contracts. So we have shows many example of contracts which are stateless. When we say stateful, you may sometime want to write a contract that you want the contract to be remembering something that happened in the past. For example, you want to write a contract that you want to be updating something, or you want it to have some specific behavior by remembering some other actions or values that were previously been goes through transaction previously. So this is documentation, and we are going to see through it, and we will explore more about the stateful contracts. So let's look at this diagram and see how stateful contract actually work. So in our previous classes, we have read some contracts, and
Please, are you recording the class, sir?
yes, I'm recording it. So in our previous classes, we have discussed on how to write a contract, and I'm sure you understand that. So in the stateful contract, the only difference is that this contract is going to be updating some properties, or is going to be remembering some actions or values that were previously interacted with the contract. So in this type of contracts, it is updating the previous transaction. For example, now you have transaction 0, the code is intact. All the business logic, all the terms and conditions that you have imposed in the contract will not change. It's only the state that will be changing. So this is transaction 0 for a contract. It has a state of 0, and if you interact with the contract again, it will be updated and the state will be 1. And also if you interact with the contract again, the state will be updated and the state will be 2. But the contract and everything, even the input, is intact. It didn't change. So this is how a stateful smart contract actually work. I don't know if you have any question about how the stateful contract work. So after this little explanation,
No
we are going.
questions, sir.
So we okay. So for us to write a stateful contract, the argument for the property by default it is pos. So you have to set it to true. So this is a property, and this property is by name count, and it is of data type big integer. So this true makes this property to be stateful, and by being stateful we can update this property count in every subsequent contract call. So when we call the contract, we can update this value of count, so by setting this property to be true, but by default it is pos. So this is how we make a stateful contract, by setting the properties. This is stateful property, and if you need more explanation about how stateful contract work, you can come to the documentation, and you can even visit the boilerplate at our GitHub repository, so that you will get plenty of information and even many example of stateful contract. But without wasting much of our time, let's put our hands dirty and do some practical stuff that you will understand how a stateful contract actually work. So we are going to write a stateful contract of a counter, and that counter will be updated will be increasing by 1. For example, now if you call the contract, it will be updated and the value of that count will be updated with 1. So if you call the contract, it will be keep updating and adding 1. So that's an example that we are going to write now. So let me open my VS Code so that you will, let me share the VS Code screen. So can you see my VS Code now? Can you see the VS
Yes.
Code, please? Okay. So we are going to write a contract, and this contract is by name counter. And what this contract will do, it is going to be keeping updating by adding 1 to the value of count. Each time it has been called, it will be updated. So let's export our class, and the name of the contract is counter. Let's write the name of the contract, and it will extend. This extend means it will extend the smart contract base class, and this extends means this our class counter should inherit everything from smart contract class. So this smart contract is a class, and this counter is our own class. So our own class is extending or inheriting from the smart contract base class, so that there are some certain built-in functions that we can use by extending the smart contract base class. So, and we are going to write a contract that will be updating the value each time the contract is called. So we are going to, this is our property, and we are going to set it to true. So any property that we have right under this will be stateful and will be updated in a subsequent contract call. So let's name this property as count, and let's give it a data type of big integer. So let me import this manually so that so this is it. Then let's move to the constructor. So a contract must have a constructor if it has at least one property that is not static. So here we have a property count, and the property is not static, so we must have a constructor that will initialize our properties there. So write constructor and constructor, so there is S here, and we have only one property and it is count. Then we are going to write count, and the data type of count is big integer. So the first statement in a constructor must be a super, and this super will carry all the arguments in the same order in which they are passed to the constructor. So in this case we have only one property that is passed to the constructor, and the name of the property is count. So we can either write count here, is okay, or we can just use split the arguments. So whether you have more than one property inside the constructor, this split argument is enough for you. It's okay, even if it is up to like 10 or much more than that. So this super argument will get you covered. So after this, then we are going to initialize our property. We have this dot count is equal to count. So we have now initialized our property in the constructor. So if you look at the contract now, we have created the class, and it is extending the smart contract base class. We have a property, and this property is by name count, and it is set to true, which means that this property is a stateful property, and it can be updated in a contract call, and it is going to be stored on chain. So we have initialized the property inside the constructor. So now what we are going to do now is to create a public method that will let us interact with the contract. So let's create a method, and this method, we'll give it this one method, and so let me import it manually. I don't know why. Method. So this method is let's give it a name. It is public, and this public is like a way that you can interact with the contract, and a contract must have at least one public method. If a contract doesn't have a public method, that means there is no way that you can interact with the contract. So this is like an entry into the contract with this public modifier. So after the public, then we'll write the name of the contract. So in this case, let's give it a name like increment on chain. So this method name is increment on chain. So it didn't has any parameter, and what this will do, we can increment the counter in the contract and the public method. So let's increment, and this is a comment so that you will be understanding what I'm going to write. A comment is a way of explaining your code so that if someone will read the code, will understand what you have done. So I'm going to increment the counter value here. So the property is count, so I can say this dot count plus plus. So this is a big integer.
Hello, sir.
Yes, are we together?
Hello, sir.
Yes, I can hear you.
Yeah, so I want to ask you a question.
Ask,
Yeah,
please.
this increment, the name of the public, increment on chain.
Yes, is the name of
So
the public
is it
method.
is it a keyword, or that is
No,
it
no,
invented the word?
no. I can write anything.
Okay.
Say, I think your name is Chide, right? I can write Chide.
Yes, sir.
So my public name is
Yes, sir.
public method name is Chide. So I can call the public method with the name Chide. That's it. So increment on chain, it is just a name given to the public method. So you can write anything. So we can write a script applica. We can write anything that we will understand, and if someone is reading our code, we understand what this method is doing. I hope you get me right. So let's name it increment on chain. Increment on chain. So this is now the contract, and our property is this dot count, and we are, since it is a big integer, so if we initialize it with the value of 0, whenever you call this contract, it will add a value of 1 to that one. So if it is 0, it will be updated to 1. If it is 1, if you call the contract again, it will be updated to 2. If it is 2, if you call the contract again, it will be updated to 3. I hope you understand. Hello, are we together?
Yes, sir.
Yes, sir. Yes, sir.
So, and if you like, you can give this one, add an assign, you can write it like this one. So it will do the same work, whether you write plus plus or you just add an assign one to it. So each way can work, each method can work. If you write this dot count, add an assign 1, so that means you are taking the value of this dot count, our property, and you are adding 1 to it. So if it is 0, it will be 1. If it is 2, it will be 3. If it is 4, it will be 5. So you are adding 1 to that count. So whenever you call the contract, you'll be updating the property. So let's leave it to plus plus so that it will be easy for you to understand. So we have increment the counter. So since it is a stateful contract and it is on blockchain, so it may carry a transaction, and that transaction will be of money, and we want to make sure that the money or the value of this UTXO didn't change, so that we can update the state without changing the value of the UTXO of the contract. So how do we do that? So firstly, we are going to get the amount that is locked in the contract. So let me show you how to get the exact value or amount of the UTXO locked in a contract. So let's say const, I'm declaring a variable. This const is a keyword for declaring a variable. You can use const, you can use let, and you can also use bar. So let's use const for this example. Const, then the variable name is amount, and it is of data type big integer, and the value of it is this dot ctx. Ctx means context, script context. So if you remember our previous class that we have discussed on script context, so you will remember this one. So this dot context, so we are going to get the UTXO and the value of the UTXO. So this will give us the amount of UTXO that is locked in the contract, the total amount of UTXO that is locked in this contract. So since we have now get the amount, so we can easily update the state. So we can update the state by still declaring another contract. Let it be the output. So it will be an output since it is a stateful contract. So the state of the contract will be an output, so that someone can interact with the contract in a new state. So let's say const our output, and it is of data type byte string. It's a byte string. So let me manually import the byte string. I don't know why I have to do this manually. So, and it is equaled this dot build state output, this dot build state output. So we are going to discuss about this build state output, build contract output, build deploy transaction, build change output, and whatsoever in our built-in function. There are many built-in functions that script has already developed for you in order to make your work very easy. So this this build state output is going to build a new stateful contract. It will copy all your contract code. It will make a deep copy of your contract and update the state and make sure that your contract logic didn't change. The amount of your contract didn't change. It will keep everything intact, and it will update the state of the contract. So and also it will update a stateful value if it is updated, and do many stuff. So this .build state output is a function that automate many work for you. If you say you can do it manually, you will do it manually. It will take a lot of time, a lot of work. So let's build the state output, and it will take a parameter of that amount, which is of data type big integer. So let's pass the value of amount here. So it will take the UTXO value as an argument, the state output. So we have now our output, and we can still handle our change output in case we have a change. So we can handle it with this .build change output. So build change output, so we can handle the change. So all these are under built-in functions. So maybe in our next class, after we have tested this contract, in our next class we will discuss about the built-in functions. There are many built-in functions, and they are very important, since you are going to be using them in your day-to-day work. So let's so now if you look at the contract, we have updated the value of the property, and we have get the contract UTXO, and view a new state of the contract. So now we are going to make sure that the unlocking, the verification unlocking transaction has the same output with our script context. That means the output of this transaction and the output of the script context are the same. So let me show you how to do that. We are going to use assert, and this assert is like a require statement, and it is it returns a boolean expression. It must either return true or false. So this boolean and also any public method must end with an assert. The last statement of any public method must be an assert, unless if it is console.log, and before the console.log must have an assert also. So this assert is used to make sure that some certain things, some condition are true. So as you can see, an argument for condition was not provided, so we didn't do anything. We didn't give any argument. So the argument that we are going to give here, we are going to hash our output with hash 256. Let me give the output. So this our output. We hash it double sha 256, and also make sure that our contract output is the same as the script context output, the hash outputs. And if it is not the same, it will give us an error saying hash outputs mismatch. So let me manually import the hash 256. It is a double sha 256. So this is a sample of counter contract, and this contract will allow you to be updating an property when you call the contract. So it is going continuously. Whenever you call the contract, it will update it. So this is a stateful contract. So whenever you want to write the contract,
Hello,
that
sir.
will
I
be.
have a question.
Yes, ask
Hello,
please.
sir.
Yes, I can hear you.
Yeah, sir, you updated something on the top.
Yes,
Like, you updated something like hash.
I am having a problem. I don't know why I can not automatically import the imports like this building things. So I used to import it manually, but as you can see in our previous video, I just used to import it automatically. So I don't know whether the project has a problem, but it is now okay. I'm just importing the smart contract, the property, the method, the byte string, and the assert. As you can see, the I keyword. So I'm importing them
Okay.
from the script.ts library, and this is property, this
Okay,
method.
why
Mm.
okay, why I ask this one is to know when to do
Yeah,
manual inputs on the top.
okay. So you two, you have created some projects, and you see that it used to be
I have a
updated,
question.
imported automatically, right?
Can I ask a question, please?
Yes, 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 please.
Okay. First of all, this at hash 256, you said is to double hash the output that
Yes,
is double of sha 256.
yes,
So
yes.
how do we know when to use either the single hash or double hash?
Yes, yeah, for you to for the hash outputs, because if you see that I want it to be equal with the hash outputs, and this hash output is double sha 256, so my output must be double sha 256. If to say it is not double sha 256, only be maybe is just only single sha 256, so I will just use sha 256 and hash my output, so that I will equate them to see whether they are equal or not. And this hashing, you will see them under how to write the contract in our documentation. There is all this hashing function with enough explanation. And if you check the documentation and you didn't understand something about the hashing, you can directly ask me in the group, or you can contact me privately.
Okay, and then because writing a smart contract, the stateless and the stateful smart contract, is it only when you want to write a stateful smart contract that you provide these informations like the amounts and then the output? If it's stateless, do we need to also deploy the contract with some amount of Bitcoin? Or just because it's stateful, that's why we are doing this extra?
So stateless and stateful are two different type of contracts, and the only thing that differentiate them is that a stateless contract, the properties and the values of a stateless contract will not be updated, cannot be updated, while the properties of stateful contract can be updated. That's why in a stateless contract we don't have to put this through, to write this through, this argument of true in the property. So we don't use to do that in a stateless contract. So in a stateful contract, whenever we want a property to be updated, we will pass this argument of true in the property. And also this amount, whenever you want to write a contract that you want to know the actual value that is locked in the contract, you can use this to get the total amount. And the reason why I'm using it now, I want the contract to be updated with the exact amount without changing anything. So that's why I'm passing the amount of the UTXO in the contract to this build state output argument. And even in case of build change output, if there is change output, I can delete this. There is no any problem. But in case if there is, I don't know which kind of transaction I'll be running. So I don't know if there is, then I can handle the change output. That's it. And here I'm hashing my output with double SHA-256 to equate them with the hash output of the script context to see that whether the output is the same or not. So that's it. It's very simple. And for this.count plus plus, you can write it in a non-public method so that you will be reusing it. For example, when you will have a more than one public method and you want to be using this.count plus plus in a multiple place, so you can easily write another method, but this one will not have a public modifier. It's like an internal method. So you just write the name of the method, let me say like increment, like this, and the return type will be, let's say, void. So I can just write this.count plus plus here, then I can easily replace this with the name of our non-public method, that is increment. So I can just write increment function. So it is also the same. So whenever you want to be reusing a method in other public method, you can just use it as write it as an internal method, and you can easily call it in the public method. So I don't know if you have any question, please.
Thank you.
Okay, please ask. Hello. Hello. So since there is any questions, so we'll call it a day. So we will meet in our next class.